Assalamualaikum and hi, my name is Mohd Zaymie, and for my part, I will explain more to introduction and understanding the problem. Okay, basically, AM transmitter is a modulation technique where the amplitude of a high frequency sound wave, most likely called radio frequency, is varied in direct proportion to the modulating signal. This modulating signal contains intended message or informations like audio data or audio message. The high frequency sinusoidal waveform is modulated by combining it with the message signal using multiplier or mixer that I will explain more later on. This diagram shows AM transmitter's waveform. This is information signal or modulating signal. This is carrier signal and this is modulated signal. The modulated waveform has enveloped shape into it. Okay, in this project, we try to implement double sideband full carrier Dsbfc into our AM transmitter. Basically, Dsbfc is one type of AM, and by definition, it is amplitude modulation with carrier. Okay, the advantages of this AM transmitter is it is simple to implement and also being cheap. And the downside is it is not efficient with respect to power usage and bandwidth, as it requires a lot of bandwidth through the process. This project, we want to have a modulated signal that have a value of output signal 3000 kilohertz or 3 megahertz with information signal of 2 kilohertz. This is our AM transmitter block diagram, simple block diagram. This is our information signal as our data. This is carrier signal. This is where the modulation process being held on, and this is our output. Okay, in this process, in this AM modulator, two signals are combined together, which is information signal and carrier signal. It is combined through a process called a mixer or multiplier, and it produces modulated signal. Carrier signal function to help the information signal so that the data can be transmitted in a longer distance. As we know, information signal has a lower frequency, so it need carrier signal with a higher frequency so that the data can be transmitted in a longer distance. That's all from me. Thank you.
Thank you, Zaymie. Assalamualaikum and a very good day. My name is HADI ibn Muhammad FADZIL with a student ID of TB18127. For my presentation, I will explain to you about our circuit. So let's get right into it. First of all is our carrier frequency circuit. So for this circuit, we use a Colpitts oscillator. So the reason we use Colpitts oscillator is that it can perform at a higher frequency. So the range is around 20 to 300 megahertz, which is our output objective, which is 3 megahertz. And the reason we choose Colpitts rather than the HADI is because it can produce more purer sinusoidal wave. And the difference between Colpitts and HADI is just the we have two capacitors which is parallel to inductor for Colpitts, and if we use HADI, we have two inductors rather than the two capacitors. The way that we can calculate the frequency output for our Colpitts oscillator is we using this equation. So if we input all the value in the equation, we can get around 3.06 megahertz. Next, we have our high pass filter, which is connected to our output carrier frequency wave, and this is to remove any DC offset from our oscillator. And the 100K resistor is also to isolate the modulator from the oscillator so that the modulator doesn't interrupt the stable frequency that generated from our oscillator. Next is our information signal frequency. So we use a function generator to generate our signal. So our message frequency is 2 kilohertz with an amplitude of 3 voltage peak. And then we have our AM modulator, which will combine our carrier frequency with our information frequency together and to create an envelope output frequency. After the output from AM modulator, we have our LC tank amplifier, which will amplify our output signal from the AM modulator to meet our requirement for our objective, which is 3 megahertz. And then from the amplifier, we will connect our antenna, in which this case we connect it to our oscillator to read any data that is given from our circuit. That is all for my part. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd bin ZULKIFLI. Today I will present part 3, the implementation with commercial components. The circuit design of the AM modulation transmitter as shown in the circuit. The output waveform will be tested by using frequency, which is information frequency equal to 2 kHz. For the first part that we use is DC supply 2 quantity. The reason is to supply power to the circuit. Second part is resistor, we use 8 quantity. The reason is to control the current flow. And the third part is capacitor, quantity is 8 to store the electrical energy. Fourth part is transistor BC107BP, quantity 2 to amplify the signal. Last but not least is information signal to plug in the frequency of the information. The operation detail of transistor BC107BP. BC107BP low noise general purpose audio amplifier description is silicon planar epitaxial NPN transistor in TO18 metal case. They are also suitable for use in driver stage, low noise input stages, and signal processing circuit of television receiver. The figure show datasheet of BC107BP. For the first leg is the emitter, second leg is base, third leg is collector. That's all from me. Thank you.
My name is Amir Umar bin Muhammad ZAWAWI and metric number TB18056. Now I will tell you the result of our project. After constructing our circuit, this is the output waveform we get. And for this waveform, we set the information signal to 2 kHz and the amplitude to 3 Vp. And this is the waveform of information carrier and output waveform. And we managed to get to our identical goal, which is 3.02 MHz as shown in figure. And this is the waveform as it passed through amplifier. We get a straight line waveform because the Vp produced is so low and we can see a visible picture that show a waveform shape. And in this project, we perform a calculation for index modulation and FC. And we managed to get index modulation 36.97% and FC 3.06 MHz. Also, as we know, we failed to get a shape we want in this project. So we managed to find some improvement for this project to be successful. First, we could use a different type of amplifier that will produce a nice envelope shape figure even after it pass amplifier. And next is we can make a better circuit design as it contribute a lot factor of producing circuit.